Hi, welcome to Unlock Layout and Design YouTube channel, and today we are discussing about ESD, which is electrostatic discharge, and this part 2 of a lengthy lecture. So in the previous video we discussed about IO pads, and then we discussed about level shifters, low to high and high to low level shifters, and then we discussed about drivers which are required to drive big capacitive loads. And then um, in this video we will discuss about what is ESD, and we will speak about how a diode works. Then we will look into like the ESD protection, which is like the primary protection, secondary protection, power supply rail protection, and back-to-back connected devices. Okay, so back-to-back connected diodes and snapback devices, difference between VDD and VSS based ESD protection, and then this human body model, machine model, charge device model. All these things we will make a separate video out of this. Okay, so the contents for this video would be like introduction to ESD, and from there all to the back-to-back connected diodes. So before understanding ESD, we must first understand how a diode works. Okay. So we all know this forward characteristic, whatever we see here. So this forward characteristic and reverse characteristics we all know. And whenever like the diode, this is the forward voltage. What do you mean by forward voltage? Forward voltage is what the applied voltage between the VP and VN. Okay. So this is P positive and this is negative, and this is VP, whatever voltage you apply here, and this is VN. Okay, that difference is your forward voltage. Okay, so if VF is zero point 0.6, then it turns on, and then like how much our current increases, the forward voltage will still be 0.6 volt. So that's what we infer from this. This is the current, whatever you are seeing here is the current I, it is in amps. Okay, and this one is the reverse characteristics. This is the V breakdown. Till V breakdown there is no current, and after once it breakdowns in the reverse way, there will be huge current that flows here. This breakdown voltage is higher. Okay, okay. Now we should understand, suppose say I connect this to ground, so this voltage is 0, so Vn, and this is Vp. Now how much voltage is required at Vp so that this diode is forward biased? So we'll come with this equation, Vp minus Vn should be equal to 0.6 volt. So our Vp should be equal to this, I will move this side, Vn plus 0.6 volt. So Vn is now 0 plus 0.6 volt. So Vp should be equal to 0.6 volt. If Vp is 0.6 volt or higher, then this diode is forward biased. Now we will connect this to some other voltage, say 2 volts plus 2 volts. Now what is the voltage that is required at this Vp? What should be Vp in order that this diode is forward biased? Again we will write down the same equation. Vp minus Vn should be equal to 0.6. Okay. So, and I will move this Vn other side. Vp is what we want. So it is 0.6 plus Vn. So 0.6 plus 2 volt. So it should be 2.6 volt. If Vp is 2.6 volt, then this diode will be forward biased. Okay. Now we will look into one more example wherein I connect this to minus 2 volt. Okay. So I am connecting a minus 2 volt here. Then what should be this voltage? This is Vp and this is Vn. So again the requirement is Vp minus Vn should always be 0.6 volt. Okay. So now our Vp is 0.6 plus Vn, or this is 0.6 plus of minus 2 volt. So it is minus 1.4 volt. So if this node is connected to minus 1.4 volt, then it is still forward biased. See, both the voltages are negative, still it is forward biased. Okay, with the fundamentals of how a diode works, let us look into like what is a ESD event and what is ESD protection. Okay, ESD means electrostatic discharge. Okay, so when a person, suppose say he's walking on the floor. Okay, so once he walks to some this one, so this guy will actually develop some charge on him. Okay, so he has got some charge, and if he comes and touches the pin of a IC, and pin is connected to the pad, and then what happens whenever this guy is charged, like he has also got like some voltage, very big voltage will be developed on him, and when he touches this pad, what happens, this charge will try to discharge through this path, and then what happens, this is at ground, and what happens is this is my circuitry which is having some voltage rating, right? All the circuit thin gate oxide. So this is the gate oxide. So how is this gate oxide? So if you see the MOSFET like this, okay, this is the gate, this is the substrate, P plus, the P minus, this is N plus, N plus. So this is the gate oxide which acts like a insulator, and this acts like a capacitor. This one and the substrate, gate and substrate act like a capacitor with a insulator of gate oxide. Because of very high voltage, this insulator will break down. So that means it will lose its insulating characteristic. That is what is known as gate oxide breakdown. If it is a low voltage device, it will be a thin gate oxide. Okay, so that gate oxide will break down. So we don't want this to happen. So what we do is we do some amount of protection. We will see to it that this high voltage whatever is there, it will not reach these devices, and then we want to protect these internal circuitry from breaking down, and that is what is known as the ESD protection. There are many ways to protect. In that, first we will see what you mean by primary protection. Okay, so this is also called as a ESD clamp diode. Okay, so in that primary protection what we have is like we have two diodes like this, D1 and D2. Okay, so let's say this is at VDD is at say 5 volt. So now a ESD event occurs here. Okay, so a big voltage starts coming here. Say some voltage goes higher than 5 volts. What happens to this node voltage? So if this voltage, so this is my VP and this is my N. This is my VP and this is my VN here. If VP goes higher than 5 volt, then what happens to this diode? This diode turns on, and what will be this voltage? So this will be 5 volt, and this will have like a minus and plus and 0.6 volt, and this voltage will be 5.6 volts, and it will not go beyond that because the entire discharge will happen from here. All the discharge will go to VDD, all the charges will go to VDD, and from there where will it go, we will see later. But basically if some voltage is more than 5.6 volt, this one is clamped to 5.6 volt. That's why this is called as a diode clamp. Okay, so only thing is, so we can see this as like this. Okay, this is the IO pad and this is my supply, which is my 5 volt supply. What should be this voltage? So 5 plus 0.6, 5.6. So that should be the voltage at this pad. So moment it is more than 5.6, it will clamp it to 5.6 only. So that's how these devices can now withstand all the high voltage, because it's all bypassed through this diode. Okay. So now what if a negative voltage comes? Okay, now we saw about a positive voltage. Suppose we get a negative voltage. So what happens here? So I have a diode like this. Okay, and this is connected to 0 volt. So what happens here? Or we will see it in the other way. Suppose say I have a diode like this. Okay, and P here, this is the P which is connected to ground. I will connect it to ground. What should be the voltage here? If here we are getting a negative voltage, here I am getting a negative voltage. For this to turn on, what should be the, what is the condition? Vp minus Vn should be 0.6. So right now Vn, we will see some voltage. Vp is at 0, Vp is equal to 0. We will find out what should be Vn for it to be on. So Vn, I will take it this side. We will take it this side. So Vn should be Vp minus 0.6, and Vp is 0. 0 minus 0.6, it is minus 0.6. So the moment this voltage, the moment this pad voltage goes to 0.6 minus 0.6, this diode is on, because this is 0 and this is minus 0.6. So Vp minus Vn is 0.6. This voltage will be clamped to minus 0.6 volt, and that's how this will be like protected. We have seen what is primary protection. Then we also have something known as the secondary protection. Okay, so strictly speaking, the diode should always be like 0.6 volt. Sometimes what happens, whenever very high current, see here the current is very high, that time this forward voltage will tend to increase beyond 0.6 volt. That time this node voltage will go beyond 5.6 in our whatever example we have taken. So it goes beyond this threshold of 5.6. Then what happens? If this circuitry is not there, then the internal circuitry can actually get damaged. So what we do is we put secondary protection to be very safe. So it consists of a resistor and again two diode like D3 and D4. So what happens is, whenever this voltage goes beyond the stipulated voltage, then this circuitry comes into picture. So whenever this voltage goes higher, there will be a current that flows and there will be a IR drop, and then this voltage will be much lower than this voltage. This voltage minus IR drop will be this voltage, and suppose say it goes to 7 volt, that time say 1.4 volt will be across this. So this should be again limited to 5.6. Okay, so 7 minus 5.6 volt, which will be 1.4 volt, will be across this resistor, and then again this gets limited to 5.6 and this diode turns on. Okay, so this is how a secondary protection works, and that's how it protects the internal circuitry. Again, this is also called as a clamped diode only. Okay, there are other ways of doing secondary protection. They can use a GGNMOS, which is a snapback device. We will discuss about that in the upcoming videos. We saw what is primary and secondary protection. Now we will look into what is known as a power supply protection or power supply clamp as they say. So ESD event can occur. So this is my VDD pad. It can occur on the VDD as well. Okay. So suddenly if the voltage goes up, say 0 to 5 volt, suddenly it goes up, what happens? So the power supply protection circuitry kicks in. So it consists of a RC delay circuit, what you can see here. Then it has an inverter and it has got a very big NMOS device. Okay, so how this works, we will look into that circuit working. Okay, whenever suddenly a voltage goes up here, this is the RC circuit. So we can write down this RC circuit like this. Okay, so this voltage is going high, 0 to 5 volts suddenly. Then what happens here? It will not, this capacitor voltage cannot change instantly. It will change with a RC delay. Okay, so that time when input is suddenly changed to 5 volt here, it changes from 0 to 5 volt. This voltage is still, this capacitor voltage is still 0. So that means this is still 0, but this is 5 volt. So this will get VGS and this turns on. So here what I get is 5 volt, which will turn on this big NMOS device, and whatever charge is there here, it will get discharged to ground. So that's how it protects the internal circuitry. There will be a very big internal circuitry here which needs to be protected from any voltage more than 5 volt. So then this power supply circuitry will trigger and then it protects. So we'll try to understand this again. So this is a RC delay circuit what you have here. So whenever suddenly a voltage changes here, this will be 5 volts, but still this will be like 0 volt, and it will increase slowly because of the RC delay we have here. I told you I have written the same circuit here. Whenever input changes, this RC delay is there. So this is still a 0, whereas this has become 5. So this will get a voltage here, and then it will come. The 5 volt will come here, and it will discharge from here. So this is a very big device. Okay, whatever is there here, it's a very big device because it has to discharge multiple current, amps of current within a very small time. So this is how this circuit works. And this capacitor need not be a MIM cap or MOM cap. It can be a MOS cap also. What is MOS cap? This one is a NMOS device, and a gate is connected here, and rest all the source, the drain and the bulk. Source, drain and bulk, they are all connected to ground. Okay, this is my power supply protection device. Okay, so as I told you in the previous slide, this device which discharges from VDD to ground will be a very big device. This will be a very big device. Why these ESD devices are big? Because they have to discharge big amount of current in small time. Okay, so it will be a few nanoseconds, but the currents will be in amps, in several amps. So they have to discharge it quickly, otherwise what happens is this resistance, it will be high and this voltage will go up. We don't want that to happen. That's why we go with a very big device. So when I have a very big device, what happens to the capacitance here? So because we have CGS CGD, this gate capacitance will be very big. So now whenever this guy is a RC circuit, which is a small circuit which triggers this, here what happens, you will get a the same whatever change happens here, 0 to 5, we will also get it here. It will still be 0 with a delay, and then this cannot drive this big cap. So what we do is we'll put some driver circuit. As we saw in IOPAD, we'll have some driver. Same way we'll have driver in order to drive this big capacitor. So we'll have a stage of buffers. Okay, so that's what will drive this big cap. So you may see in a power supply rail protection not only a simple RC, a inverter and a big transistor like this, but you will also see few buffer stages which are like increasing W by L. If this is W by L, maybe this will be like 5 times or 10 times of that W by L, and then this will be 10 times of this W by L2. So 10 times increase you will see, so that this is a driver buffer. Okay, and this one need not be always a MIM cap or something. It can be even a MOS cap like this. Okay, so the bulk is also connected to ground and this gate is connected to this. So this can be even a MOS cap. So the general idea is what is explained in this. Okay, now we will look into the overall big picture, right? So whenever a pad voltage goes high, 0 to say some 5.6 volt, so here it will be like 5.6 volt only, and this node voltage will be around 5 volt. So what happens to this discharge? All the charges will come here, and this node voltage will be 5 volt, and it will go here, and then this node voltage is now 5 volt, and you will get a discharge path. Because of this RC, it will go up like this. This will turn on, and then the 5 volt will come here, and this will discharge to ground. So if you see, the entire path of the discharge will go from here and it will go to ground. So this is the path of discharge, and this is called as VDD based protection, ESD protection. So because the ESD event is like going through this one, and when you have a negative, so it will be from here, it will go from negative to, it will go from 0, from ground to minus this one. So this is the path of the ESD protection. So this is how it works. So they all work in they all work together. This IO pad will discharge through the VDD pad. Okay. Now we will see the entire ESD protection, how it looks like. So what do we have? We have what is known as the primary protection. Then we have this one R and these two diodes. They become the secondary protection. This is the entire internal circuitry, which is my the entire circuitry which I want to protect. So there will be lot big. This is a very big circuit. Okay, and then we have the power supply clamp or the power supply protection. This entire thing, this RC, and this can be a single inverter or a series of inverters, which is like a driver circuit. And I have a big NMOS transistor here. That's how this works. Okay, and this is the entire power supply and IO pad protection. This is the protection circuitry. Okay, in some cases there will not be one VDD, there will be multiple VDDs. Okay, there will be multiple VDDs and all of them have to be protected. Okay, so whatever circuit is there here, whatever circuit you see here, protection circuit for VDD1, I will have a similar protection circuit for VDD2. Okay, similar protection circuit for VDD2, and this is just this same circuit flipped here. Okay, I have just flipped so that VSS1 and VSS2 are coming next to each other. So I have just flipped the circuitry, and so then what happens is we must protect the entire thing. If at all this triggers, there must be a path to discharge through this ground. So what we do is we connect back-to-back connected diodes like this. So now anything, this voltage goes higher, then this will turn on. If this voltage goes higher, then this will turn on, so that our entire circuitry is like protected. Suppose say VDD1 some ESD event occurs, so there will be like back-to-back connected diode here. Okay, so it can discharge from here also, this power supply clamp also, or if a ESD event occurs here, it can discharge from this clamp also. So that's why we also see back-to-back connected diodes when you have multiple VDDs, VDD and VSS. Okay, so this is also one other type of protection. Okay, to summarize, what do you mean by ESD? ESD is electrostatic discharge. What happens is like a very big voltage is developed on a person. Okay, and this, when it comes in contact with the IC, will try to discharge, and there are various types of protection. So what is known as the primary diode, this diode also will be very big. Okay, it has to carry amps of current within very small time. So this will be very big device. All these devices will be big. All ESD protection devices will be big devices. Okay, this is known as the primary protection, and if at all this fails to clamp the voltage, then the secondary protection will pitch in, and then like this will try to protect beyond this voltage, and these two are the primary and secondary protection. And from power supply to ground also we have to protect. So that time any high voltage comes here, so then what happens, this RC delay will create and this will turn on, and it will discharge from VDD to ground. This is my power supply protection. And if I have multiple VDDs and multiple VSSs, we will have like back-to-back connected diodes, and these are the different types of protections we will see in ESD. So now how to set this threshold voltage? So we assume that it was 5 volt, it could be 3.3 volt, it could be like 1.8 volt, whatever is the threshold voltage. How to set that threshold voltage, all those things we will discuss when we discuss in the next video about snapback devices. That time we will discuss about all the ESD, entire ESD event, what are the different types of ESD events, and how to protect, and what is the voltage by which we have to protect. All those things we'll see in the upcoming video. So thanks for watching, hope you like the video, and if you have any questions, please post it in the comments section, and don't forget to hit the like button and also share and subscribe. Thank you.